Okay, so I think this is the perfect time that we should stop and just have a look at what is actually going on. Okay, and yeah, so here I have drawn my diagram. So I'm doing this just because so that you can absorb the idea of what is going on and just you just don't get khajal in all this. Okay, so here I have drawn my diagram again, which is x square. Okay, x versus x square, and I have drawn out my two limits. At the first limit is at 1, x equals 1. The second limit, or the second boundary, the first boundary at x equals 1, the second boundary here at x equals 2 to get a closed figure. So now, okay, so as I had said earlier, okay, I had divided the shape, this given shape, into three rectangles. Okay, so I'll just do that again. Okay, so I'll just make three rectangles here, and there you go. Okay, rectangles. And let me just shade the area of the rectangles. The first rectangle, the second rectangle, okay, and the third rectangle. So these are the three rectangles, and I've shaded the area of the rectangles. Okay. So now I had also asked you to do the same thing on paper, right? But I think it will be better if I demonstrate this here in the video. So yeah, let me do it on paper for you. Okay. So here I do it. Okay, so here I have the paper. Okay, so here I have the diagram again on paper. This time paper. This is pure, simple paper. So what I'll do is I'll simply cut out the first. I'll cut out the whole shape, the shape whose area we have to find out. So the shape. Okay, this closed figure. I'll just find the area of that. So I'll take a scissor. Please pass me the scissor. Thank you. And I'll cut out the first. First I'll just cut out the shape. Okay. Okay, so I'll just cut it in front of you. So here I'll just take the scissor, and first I'll cut across along the x square curve. So here I'm cutting it along the thing. So going along the now. So there I go. I don't need that part. I cut this part also. Not needed. I'll just cut this edge also along the boundary at 2 at x equals 2. I'll just cut the area below the x-axis also. So okay, and yeah, I suggest you try this activity yourself also, because this just needs some paper, and I'll cut the area before x equals 1. So this is my this x equals 1, x equals 2, and this is the area that I have to whose area I have to find. This is the figure. Okay, now what I was planning to do was cut the shape into these three rectangles. Okay, so I have shaded those rectangles out. So I'll cut the first rectangle out. So what I do is I cut this out. I find its area. So this is just a rectangle. I find its area. This is what I was planning to do. So I'll just keep it here, the first rectangle. Then what I do is I cut out the second rectangle. There I go. That's the second rectangle. I find its area, add it up to the area of the first rectangle. Then I take the rest of the figure, cut out my third rectangle. Okay. Okay, so here I've cut out my third rectangle also. So I find the area of the third rectangle also, and add it up to the rest of the two. Okay, so what I end up with is three rectangles here. So these are simple rectangles, three rectangles. I find the area of those three rectangles, and because they have been cut out from this figure, so I can say that the area of these three rectangles is almost equal to the area of the original shape. Okay, that shape that we just had cut out. So this is the area that I find actually. So this is the area that I find. Okay, the area I find. Okay, and but here if you can see, here is some. This is the area that was still left. So this will cause some problem, right? Because this is the area that we haven't accounted for. Okay, so I have found the area of those three rectangles, but this is the area that is left, and if you see, that's quite a lot of area. Okay, so now let us do something so that we can reduce this area and include this area in those rectangles somehow, so that the area of the rectangles gets closer to the area of the whole shade that I had just cut out. Okay, so let me make another diagram. Okay, I'll just do this again, but instead of three rectangles I'll make five rectangles. Okay, so I'll just draw the graph again, and this time instead of cutting into three rectangles, as I said, I'll be making more rectangles. So Okay, so here I get my shape. So what I do is I'll quickly draw 4 rectangles, okay, instead of 3. So here I go, okay. So I'll just draw 4 rectangles on this. 4, let's say 5, okay, 5. Let me draw 5 rectangles. Okay, so there I go. So I've drawn 5 rectangles this time. Okay, and I'll just shade the area of them. The first rectangle, the second rectangle, and the fifth. What did I say? First rectangle, second rectangle, third rectangle, fourth rectangle, fifth rectangle. I shaded all of them. There you go. Okay. And now I'll just cut them out quickly. So here I take my scissor. And okay, so first of all, as I did in the last video, I'll first of all cut out the shape that I want. Okay, the original shape. Okay, the original figure that whose area we are finding, not work. Get out. I'll cut it at the boundary x equals 2, and yeah, I'll cut the area below the x-axis also. Also, if you see the x-axis, the curve, the boundary at x equals 1 and the boundary at x equals 2, all are working together to restrain. Okay, so to form a closed figure here, whose area we are looking for, trying to find out. Okay, just get the cut a bit more clean. Okay, so there you go. So this is the shape whose area we were finding. Okay, this is the same shape that was in the previous example also. And now I cut out the rectangles. So here I go. I cut out my first rectangle. I keep it here. So I find the area of the first rectangle in this time. Okay, in this attempt of finding the area. And I hope you would also do this at your home, because that will just make the whole idea a bit more clear in your heads. And yeah, that is okay. So there is nothing bad in trying this at your home. So I just cut out the second rectangle, and now I'll be cutting the third rectangle. So there you go. The third rectangle, I find the area of the third rectangle and add it up to the rest of the rectangles. Then I cut out the fourth rectangle. Okay, there you go. So I'll cut out the fourth rectangle. There you go. I find the area of the fourth rectangle again, add up the rest of the rectangles, and finally I cut the last rectangle and find the area of the fifth rectangle, add it up to the rest of the rectangle, and again I'm left with some area. Okay, so here let me just show you the rectangles first. So these are the rectangles. Obviously they are of equal width, but as you can see, okay, so I have 5 rectangles, so I have more rectangles, but that doesn't mean that I have. So here you can see these are less wide, obviously, because I have more number of rectangles, so each rectangle is less wide. And now in this case also I have been left with some area. But if you compare, this is the area in this case, and in the previous case I had larger rectangles. Okay, so the area of these 3 rectangles, okay, is clearly more than the area of these small rectangles. Okay, obviously they are 5 in number, but they are very small as compared to these rectangles. So clearly this area is larger, this area is more than this area. So this shows that so this is the area that is being neglected, right? And this is the problem. Okay, this is the problem that we are trying to eliminate somehow. So as you can see, we've reduced the area being neglected. So what we want to do is, okay, so we want this area to be least. Okay, so what we just did was increase the number of rectangles. So this clearly shows that if we increase the number of rectangles, this area, the extra area, is obviously being reduced, and so we should increase the number of rectangles as much as we can. And to increase, as we just saw, when we increase the number of rectangles, we reduce their width. Okay, we just saw. So we need to cut out very thin rectangles and as many rectangles as we can, and so we get our best approximation. Okay, so what I now do is I get to the third shape finally, and I'll just cut out the shape. Okay, quickly. Okay, so here I'm cutting the shape into shape. Okay, so I'm just cutting out the figure from the graph, and then I get rid of this piece. I get rid of the rest of the pieces also. And yeah, this is the Okay, so here I've cut out my figure, and now okay, so I'll be trying again to cut this into rectangles, but this time I'll try to keep the rectangles as thin as possible and as many as possible. Okay, so I'll keep them, try to keep them uniform. Obviously I won't be able to do that because I'm a human being. Okay, but I'll try my best to keep those of equal width. So here I cut on my first rectangle. There you go. This takes a lot of effort, obviously, but if you see, yeah, there you go, my first rectangle. And if you can see it, if you can see, this is a rectangle, right? This is a rectangle, as you can see here, but obviously this is a very thin one. Okay, so but this is a rectangle, and I can find its area simply by multiplying the width of this by the height of this. Okay, so I carefully keep it here. Okay, I won't lose it, and I do the same thing again. I cut another rectangle. There you see. Wait, I'll just cut it out. My second rectangle, again thin one, and I think the length I've tried to keep almost equal. This is a taller, but okay, of the equal width. And so I'll just quickly cut this out into many rectangles, and I'll just show you the result. Okay. Okay, so here I have collected the three figures that I had cut into rectangles, right? So these three are almost the same figures. They have the same area. So they represent the same shape after all, okay? So in the first case here, I had divided the... so I'll just give you a closer look. So here, in the first case, I had divided the whole shape into three rectangles there. Yeah. So I divided the whole shape into three rectangles, and the first rectangle. So what I was intending to do, so our aim was to find the area of the whole shape. So I divide the shape into three rectangles. I find the area of this rectangle first. So length into breadth, okay, or width into height, as you may say. Again, I find the area of this, width into height. Okay, so I have tried to keep the area width of the three rectangles same, just for simplicity's sake. Okay, so this into this into this, I get the area of the two, and then I find the area of this third one also, width into height, and I find the area of these three. So obviously the area of these three, the total area of these three is not equal to the whole area, because we've been left with this area here. Okay, and this is not at all negligible. So what we did in the second case was we increased the number of rectangles to 5. So here what I did, what I did was I've divided the whole shape into 5 rectangles, and here to find the area of the whole shape, I find the area of this triangle rectangle by rectangle. Did I say triangle? Okay, so what I mean is rectangles. Okay, so even if I say triangle, it means rectangle. Okay, sorry for that, for the mistake. So I find the area of this rectangle, width into height. I find the area of this rectangle, then okay, width into height. Then I find the area of this rectangle, width into height. Again, I kept the width of all of them equal, and then I find the area of this, and then this, and then add all of them together, so as to get the area of the whole shape, which I don't think is okay. So even here I've been left with some area, this area, but this is less as compared to this area. So this is a better approximation of the total area. If I find the area of this and say that this area is the area of the actual figure, that will be quite a good approximation, because the area is not as much as in the previous case, but I can make this approximation better by doing this. So I had the same figure, but this time I divide the whole shape into many small strips, rectangular strips. So they are after all rectangle. So I take the first rectangle here, as you can see, find the width into the height, and I kept the width of all of them almost equal. So I find the width of all of them. So what I do is I take the second rectangle. Okay, this is the second rectangle. Okay, here, and I find the width of this one into the height, and I multiply and find the area of this. So find the area of this, find the area of this, find the area, and so slowly I find area of all of them. Okay, it's a tedious task, obviously, but okay. So what I do is I find the area of all these small rectangles somehow, and then what I do is so then I just add them up, and then if I say that the area of the total area of all these rectangles is equal to the area of the original shape that I had made, that will be a very good approximation. Why? Because the area that has been left is only this small strip here. Okay, and if you see, this is pretty negligible. Okay, and the point I'm trying to prove here is that if the width of the rectangle is very very small, as in this case this is very small, right? But if the width tends to 0, okay, now if you are familiar with the idea of limits, you'll understand this thing. If you're not, go and check the Khan Academy video on this topic also. So I'll just show you the notation in a moment on the board. But what I mean to say is, the point is that if the width of my rectangle is almost 0, it tends to 0. Tends simply means almost, okay? So the width of the rectangle is almost 0, as or negligible, or as low as possible, okay? The area of this rectangle summed up together is almost the area of the whole shape. That is the point I am trying to make in this video, and please absorb this idea, because that is the whole basis of integral calculus. And if you don't get this point, you will not be able to understand the subsequent videos. And if you understand this, all is good, okay? So that is the area that you're neglecting, and we can simply neglect that, okay? And this is the area we're interested in. Now we'll continue that discussion in the next videos of how we find the area of all these rectangles, okay? Because if you do it physically, it is very tedious, but if you do it mathematically, so that's the beauty of maths. It simplifies such tedious tasks into very simple calculations. So okay, so that we'll just see in a moment. Okay, so finally I just tell you the notation of how we write this whole thing. So we denote our width of the rectangle if we denote it by h. So what we write is h tends to 0. This means h is almost 0, not 0. There's a lot of difference between being 0 and being almost 0. So here h is almost 0. The width is very less, almost 0, not 0, almost 0. So here we say h tends to 0, okay? So this is we usually write it as limit, okay, lim, okay? And I'm sure you must have done this also in some other class with Kunal sir. Okay, so here our limit tends to, here a limit h tends to 0, okay? So and this is just a notation how we write that, and rest we are just summing up the area, and let's continue the whole discussion in the next video. Okay, bye.